Recording is rolling. It is Friday, October 4th. I'm going to have you guys build this Varignon frame today. You guys have a lab page that goes with this. All right, so I'll show you guys that in a minute. But here, some other stuff. Guys, what's due on Monday? Take-home quiz due Monday. A bunch of you guys did already turn your puzzles in, but if you haven't, then turn this in by Monday also. And how about this coming Wednesday? Where are you guys going to relocate to? The media center. This particular classroom used for testing. We're going to be media center. Well, I'm going to be in the media center all day. Unless, of course, you are testing in PSAT, in which case go to your classroom that you're supposed to be testing. All right. So let's say Varignon frame. So here's the premise. Let's say we're going to build a factory. We've got different input variables, and maybe there's a town we're going to ship the product to. Maybe I need some lumber from the forest, some copper from this copper mine, and I'm going to make something and ship it, maybe like a box of pencils, and send it to the town. Okay? And maybe each of these resources or final product has different associated transportation costs. For example, what if it was particularly expensive to transport the lumber? Maybe it's big and bulky and kind of hard to manage. And besides that, we get to the factory, we're going to shave a bunch of weight anyway. So we got all this extra weight we got to carry around. Guys, if it was really expensive to transport the lumber, would you want to build your factory very close to or very far away from the forest? Close to. It makes sense, right? So that's the question is, what is the optimal location to build the factory to minimize transportation costs? Right? And you guys are on the right track. Is okay, well, if it's more expensive, we should build it closer. There's a physics answer to this question, the physics solution, which is to build this Varignon frame. And you can hang weights over, on strings, over pulleys, and the weights can be proportional to the transportation cost, the relative transportation cost, like that. So let me show you guys this in action. I've got a video. If you want to see this full video, it's on YouTube. I just type Varignon frame, and this is the first one that pops up. Hey, does this look like a map? Do you guys see a map? Big old map, right? All right. Now, here's a paper cut out of a factory. This is where a bunch of strings are tied together. Kind of hard to see strings, but I'll flip the screen here a minute. You guys see 1, 2, 3, 4 pulleys. Now, I'll have you guys do 3 pulleys. They've got 4. But you can have any number of, say, inputs or output. Let me zoom back a bit here. Good. Do you guys see that string? You guys see string? All right, so that string goes through this pulley. Okay, string goes through the pulley. Got that. Zoom around a little bit. All right, we're going to be hanging these weights. Now, if some relative transportation costs change, you can change out the weights. Do you think it's going to change the position of the factory? Let's see this in motion. This works. All right, so wait, and look, see it shifted. You guys see it shifted? I think he does another one. Let's see if he does another one here. So different set of weights. Boom. And the factory position changes again. All right, let's go back to the map. See what does this look like from above? Right, so it's going to change the weights underneath, and the factory moves as the result. All right, you guys got that? Got the premise? All right, let's switch back over here. All right, so you guys have this lab paper. How's this lab paper going to work? So I have 3 different scenarios for you guys. One is an example that's completely filled out, so you don't really do anything, although you can kind of reference it to get the idea of what I'm looking for. Right. Now, scenario A, I gave you guys some lab weights. Right. Guys, 500 grams weighs how many newtons about? Is that 5 newtons weight? Right. How about 400 grams weighs how much? 4 newtons. And I have 200 grams right here. To lift it, how much weight is this? 2 newtons. Okay, so do you guys think that would correspond to the tension in the string? Maybe the tension could go like 5 newtons, 4 newtons, 2 newtons, something like that, right? Right. Now, what I did not list and what you guys are going to fill out is the locations of these things. So you can make up whatever location you want. All you have to do is put these pulleys around the lab table. This could be, say, a lab table or something like that. Okay. Now, how can you measure a location? Well, you can treat this like a Cartesian plane. So here's what you're going to do. I'll walk around and help you guys out, of course, too. Is pick a corner of the lab table and assign that 0, 0. Could that be the origin point of Cartesian system, 0, 0? Right? Maybe the x-axis represents how far east from that point, and the y-axis represents how far north from that point. And each of these 4 locations has an xy coordinate. So maybe the town could be the lab table width across and a few centimeters up. Here, I'll give you guys a hint too. The lab table width turns out, I think I wrote this on this paper, to be 122 centimeters wide. Okay, so that could save you stuff. Oh, you have meter 6 back there. You can measure that anyway. Okay, so it looks like my town is 122 centimeters over, and maybe just eyeball it, maybe 10 centimeters up. So under town's right here. I'd write 122.10, right? Like a coordinate. You see that? Right? And I would be attaching on this weight right here for the town. Maybe it's cheapest to transport the pencils. Maybe they're in the boxes, least amount of material. It's all been shaved away. It's in convenient boxes. Probably the smallest transportation cost, I'm guessing, something like that, right? Now these other ones maybe have other associated weights, right? But this has an XY coordinate to the forest, an XY coordinate to the mine, and then this factory is going to naturally set up at some place. It's just where the strings are tied together. This could be some natural equilibrium point. So you can measure. Here, this was like a meter stick. How far over? How far up? And you get a coordinate, and then just record that coordinate where you put the factory right here. You guys got that? Right. Now, scenario B is more open-ended. Now you can come up with your own relative transportation costs. If you want to keep the same or different locations, you can do that. Right. And then I bet the factory might be end up in a new location. You see that too? Right. Good so far? All right. Now, my classes so far, a lot of teams, they get to about that point and we have like 1 minute to in the class. So just focus. If you just do the front, that's okay. But just while I got you guys right here, let's look at the back side, which probably won't have time for. That's okay. Oh, what am I getting at here? So what if you have 3 strings and here's the factory in the middle, and I want to do an equilibrium check. Now this side here's really the poster that goes hand in hand with that. You guys remember this guiding principle from, like, this could be like the factory point, right? Is if you break these weights into components, these I guess these string tensions into components, doesn't the right and the left zero out, and this up plus this up minus this down also zeroes out? That's the guiding principle you can use to solve stuff. We did some of this in class, right? So let's see if you guys are following here. If you know these string tensions, 1, 2, 3 string tensions, you can record those tensions here. Let's say you take this protractor and you measure these angles, alpha and beta, right? So then you can break those into components, right? Oh, so how much east is this one pulling? How much west is that one pulling? Guys, what is the east component minus the west component? What should that equal to about? What is this east minus this west? Zero. And then this one's pulling a little bit north. This one's pulling a little bit north. This one's pulling a lot south. What is a little bit north plus a little bit north minus a lot south? Plus minus. What is that? Zero. It should be zero. Okay. Again, you probably won't have time to do that part. That's okay, but show you guys where that would be leading, like ideally what that would be. All right. So I'm going to leave this on the projection during class. Go ahead, just finish the front page of that paper and turn it into the gray tray. I'll walk around and help you guys out. Varignon frame.